Hi everyone, so let's do one interview question called merge intervals. So over here we are given an input which is a two-dimensional array. So what we have to do is we need to merge the intervals and give the output as the two-dimensional array. So what do you mean by merging the intervals is, so suppose we have 1, 2 and 3, 5. So if we draw one number line, we have 1, okay, 2 and 3 and 4 and 5. So if we draw this number line, 1, 2 falls over here and 3, 4, 5 falls over here. So there is no, it doesn't, this one doesn't come under this one. So there is no, we don't need to merge over here. So we put 1, 2 in our output array. So 1, 2 and 3, 5. So we need to merge only the intervals which are mergeable. So wait, I'll explain that one. So now it is 3, 5, right? So now so now look at the next one, 4 and 7. Now this 4, 7, look at 3, 5 and 4, 7. Now this one can be included in this interval, right? Because 3, 5 is this and 6, 7. So 4, 7 can be included over here. So this one can be merged. So what we do is, this is not 3, 5 anymore since it can be merged. So we merge this one. So this, we compared these two numbers and we got to know that we can merge them, right? So we can, if we change this one to 7, so it means we have merged these both. So this 3, 7 will include 3, 5 and 4, 7. So we have merged this one. So now let's look at the next number, 6, 8. So now again this 6, 8 can be merged with this one, right? Because 3, 7 includes 6. So 6, 8 can be merged. So we cancel it and we make it 8. So next we check for 9, 10. Okay, so if you look at 9, 10, so if you look at 9, 10, it starts from here and 3, 8. So there is no merging in this level, right? Because we can't merge. So we just add it to the end result like this. So that's it, guys. So this is the answer. So 1, 2, 3, 8 and 9, 10. So suppose if we have something like this one. So if it is 3, 5 and let's change this to 5. Okay, so then also it is mergeable. So if we try to merge these both, we should be getting 3, 7, because 5 it coincides. If 3, 5, okay, then this is 5, 7. So it coincides, so it is inclusive, so it coincides to 5. So we merge to 3, 7. So we should keep that in mind. Okay, so next thing is, one more thing you need to do before doing this process is, it should be arranged in this, it should be arranged in the alphabetical, ascending order, okay, of this first element. So we need to arrange this whatever intervals we have in the ascending order of the first element. After doing that, we can continue to solve. So So one second, so how do we go about doing this? So let's try to do this with an algorithm. Shit, what happened? Shit. So okay, okay, yes. Okay, so how do we do this with the help of so let's come up with an algorithm to solve this. So first things first, we need to sort this one with respect to the first index. So if we don't sort, like, we will get the wrong output if we apply this one, because if we have like 3 comma 5 and 1 comma 2, it will coincide even though it doesn't. So you can self work out that one. So anyways, this should be sorted. So now this one is already sorted. So how do we go about doing this is the second step is you need to add the first element to the result array. So we'll just add this one to this one. Okay, is the first step. So and the next step is we need to check if the second if we need to add this to the result array, and then we need to iterate over this array starting with the second element, that is this one, I is equal to 0. Now we need to start off with I is equal to 1. Okay, so we need to start off with this one. So this is the current element. So we need to check for this one, previous second element to the current first element. So 2 is lesser than 3, right? So we just add it over here. Okay, so we add this one. Okay, so next, after doing this, we need to, here also we'll be having one RI, result index pointer. So after doing this 1 comma 2 and 3 comma 5 is 3 comma 5. After adding the new element to the result array, we just move this one by 1. Okay, so next we move this one also over here. Okay, so next we go over here. So we check for, we have 4 comma 7. Okay, so now we need to check again, do the same thing, check for what's happening. Okay, check for this one with the previous second element to the first element of the current. So this is the current, so this is previous. So 3 comma 5, so 5 is greater than 4, so that formula is Okay friends, something is happening here. Give me 1 minute. I can't write anything. Okay friends, yeah, sorry for that. So let's continue. So now we create a pointer pointing to the second element, and we have added the first element to the result. So after that, so here also let's create that pointer. So we have added the first element and the pointer is pointing to this one. So after this, let's move this one to here, the next element. Okay, so now what we do, so what we do is we check for the end. This is the previous and this is the current. So we check if previous end is, if previous end is lesser than okay, wait, so what we do, one second. So 1, 2 we have added over here. So next the pointer so the pointer is initially pointing to this. So the first element we add to the array. Okay, so the first time it is pointing to 3, 5. We compare this 2 with this with the previous second number to the current first number. So since previous second is lesser than this current first, we just add it to this one, since there is no merging. So we just add this one like this. So 3, 5. So after adding, we move this one to here. Okay, so after doing that, we move this one over here. So next what we do is 4 is less. So now we compare this one with this one. Okay, so this is the previous. So if previous last number, so second number or last number, is greater than current first number, so then there is one merging, right? So if this is the case, what we have to do is previous last number is equal to the biggest is equal to the maximum of previous last, and is the maximum of this one and this one, whichever is the maximum. So maximum of this one and this one. So current second num comma previous second num. So over here we get previous last number is greater than the current first sum. So previous last number is greater than the current first sum. So yes, there is one merge. So we need to change this previous last number to the maximum of this current second number, and whichever is the maximum, this one or this one. So now since this one is the maximum number, we need to change this one to 7. Okay, so after doing this, let's move on to this one. So now again we do the same comparison. If previous last number is, this is the previous last number, is greater than the current first number, yes it is. So maximum of, so this previous last number will become the maximum of current second number 8 to this previous second number. So since this is the maximum, it will become 8, this one. So previous last number is equal to maximum of current second num and previous second number, so this one will become 8. Okay, so after doing this, we move this pointer over here. So now in this case, the previous last number is lesser than the current, is lesser than the current first number. So in this case we can just add it to the result array, since there is no intersection. So we do like this 9, 10. So this should be greater than or equal to. Why greater than or equal to? Because even if it is, I told that time, right? So even if it is 3, 5 and 5, 7, it coincides. So we need to check for that condition also, equal to condition. So that's it. You got it right. So this is the first condition. So I'll write the first condition also. This is the second condition. So the first condition is if previous last number is less, if previous last number is lesser than current first number, then just add it, add that array to result. So that's it guys, this is condition 1, this is condition 2. So let's solve that one. So so first step is let's sort the array. So int, I'll just store this to a new variable. sorted intervals is equal to intervals. Okay, so arrays dot sort intervals, comma, intervals of 1 second. I'll just sort this. Okay, so now this one is sorted. So after sorting, we create one new array. So which is the result? We will create a list. This will create an int array. So result is equal to, so we are creating this one right now. So result is equal to new array list int array. So after creating this one, so we need to do the first step. Add the first element array of input to result. So result.add result.add new int intervals of 0 0 interval sorted intervals of 0, 0 and sorted intervals of 0, 1. So next, yeah, we have added the first element. So let's run this. There should be one double dimensional array. It cannot be converted to teacher. So the result is one double dimensional array, so we are adding result.add new int result.add. Okay, now it's correct. So we have added the first element to the array. So this is step 1. Next step 2 is to iterate. So for int I is equal to 0, I lesser than intervals dot length and I plus plus. Okay, so we iterate. Before that, so since we have added this one, right, so we need to create one result pointer, int rp is equal to 0. So now we should iterate from 1, since we iterate from second element. So this is important, we should iterate from the second element, that is 1, since indexing starts from 0. So if this is this thing, so first we'll just take out the result. So previous last number means, so previous last number int previous last number is equal to what is that? How to get the previous last number? So rp, we can use this pointer. So now currently it is 0. So result dot get of rp. So if I do result dot get of rp, I get an address pointing to one 2-dimensional array. So that one I can get by so if this one is result dot get int arr, so I'll get previous array. Okay, so next internal okay. we'll get one single dimension. Previous last number is equal to prevArr of 0. So last number is 1, previous first number is equal to ARR of 0. So after hitting this, do the same thing. So we got this one. Okay, we need to get this one also. So int currentArr is equal to in sorted intervals, should also be sorted intervals. Sorted intervals dot sorted intervals of I. So int current first number is equal to currentArr of 0. So int current last number is equal to currentArr of 1. So let's look at the first condition. If previous last number is lesser than current first number, previous last number is lesser than the current first number. So add array to the result. How to add that to the result? So result.add and next do immediately after adding we need to do rp++. So result.add currentArr else if previous last number current first number previous ARR of 1. It is the previous last number is equal to Math.max of current last number and that's it. So after doing this I will return once I should convert this result to an array and then return it back. Let's run this. 18 okay. So we got one two-dimensional array. So previous of rp of 0 of 1 28 integer I cannot be converted to. List of integer array result.get of rp. 13, line number 13. Should be a single dimensional array. Mm, 33. What is the issue? Math.max. Let's look at that. I don't know. Math.max. Math.maximum of. Here cannot find symbol. Oh, current last number. It can't find this one. Spelling mistake. And this. Okay. Now test done for all. Run code. Come on. Yes. So that's it, guys. This is how you do it. So these are the steps. So step 0 is to sort according to the first integer. I'll just write this down. Step 1, sort according to the first integer. I'll call it step 0. So step 1 is add the first element array to the input result of input to, so whatever is the first element in interval, so it should be added to the result. So step 2, iterate from the second element. So here we are just getting all the elements. So step 3 is do this condition else. Step 4 is we need to do this condition, and while returning we need, since we are adding everything to result, we need to convert this result to an array and then result and then return that result. So that's it, guys. So time complexity for this one is time complexity is O of n, okay, where n is the number of elements in number of arrays in these intervals, and space complexity is the again O of n, because we are creating one new result and we are adding the number of arrays to this one. So it is O of n and O of n. So let's check it out. Oh, sorry guys, it should be time complexity can be taken as n log n, since we are sorting that array. So it is so the sorting array will take n log n. So then this one will take again plus n, because we are iterating only once, but we can ignore this one. So it will take n log n time complexity and O of n space. So that's it, guys. Thank you for watching.